nüüd on mul hea meel anda sõna meie esimesele esinejale, kes on siis Norrast, Bergeni ülikoolist, Helge Drange. Ta on põhjalikult tegelenud kliimamuutuste mõjude analüüsimisega ja nõustus meiega täna oma teadmisi jagama. So Helge, I made a short introduction to you in Estonian, promised that you will tell us today about the climate change and its consequences to cultural heritage and what is the relationship in between those two. So please, the floor is yours, and welcome.
Yeah. Thanks a lot. It's a great pleasure to be here. I have never been in Estonia, so that would be even better. But from a climate perspective, this is actually a very good substitute. So let me see. I have some slides here, starting with this one. So we are now 1,000 kilometers apart. So let's see if I get this running. There we are. At about the same latitude. Bergen has a very coast climate, ocean climate, whereas in Estonia you have a more inland climate, but there are similarities. So I have some slides there. All of my slides and also the animations, they will be available. So I will pass that to the organizers, so the attendees can get a link to download the slides if you are interested. And I start with this global view showing in white color the total amount of water vapor in the atmosphere. And where the white color goes into blue, then we have heavy precipitation. So this is an animation that we made some years back, but it's still valid. And we see that most of the water vapor is coming from the tropics simply because of the heating from the sun. And we also see that there is a tendency of the water moisture to go, if we are on the northern hemisphere, to go northward and eastward. And this is because of the rotation of the Earth. So therefore we have these arrows, they indicate the main transport way, so to speak, of moisture or whatever it is in atmosphere. And the Nordic countries, including Estonia or the Baltic region, are marked here in red. So we see that at least in summer, autumn, into winter, we get a lot of air masses from the Atlantic, certainly for Bergen, but even also for Estonia. And what's happening today is that we have global warming, so the temperature is increasing everywhere, including in the tropics. And whatever happens in the tropics, then this perturbation or signal will be transported to each hemisphere. And this transport is going quite fast. And the temperature now is increasing also in the tropics, and this is influencing our region. And this animation also indicates that what happens on the local scale, whether it's in Tallinn or in Bergen or elsewhere, may originate far, far away. So we all belong to the same planet, as we know, and we have a common destiny, so to speak. So I will say a little bit about the background for global warming, climate change. I will show some of the findings regarding your region, and I will also point towards the emission reductions that are needed in order to limit the global warming to either 1.5 degrees or 2 degrees centigrade. And one backdrop here is the latest report from the Intergovernmental Panel on Climate Change that came out, I guess, in August this year. And this report is available on the net quite some thousands of pages and possibly not the easiest to read. There are some headlines there. This is just cut and paste from a press release from Reuters, but the headlines there are quite good. So we, climate science, are absolutely sure that humans are to blame. So that was point number 2. We also, unfortunately, are very confident that the temperatures will keep rising, of course, depending on how much greenhouse gases we put into the atmosphere. Something that is new is that we now are able to state that there is a link between human-induced greenhouse gas emissions, climate change, and extreme weather. And that is both extremely high temperatures and also heavy precipitation events. There is a point here that we foresee that the Arctic will be more or less free of ice in the summertime, possibly around 2050, not in the winter, but in the summer. And also the sea ice in the Baltic will gradually be reduced and disappear through most of the year. The sea surface, sea level, will increase irrespective, unfortunately, of what we do. I will come a little bit back to that. Estonia, the coast of Estonia, is a little bit protected in the way that the land is uplifting. But still, also you already now experience, and you will experience, continued sea level rise, and time is short. Yes, not very positive headlines there. And another headline that is also on the negative side is that almost irrespective of what we do now with greenhouse gas emissions, we expect that we will have a 1.5 degree warming sometimes in the 2030s. And although the politicians still have 1.5 degree target as the political target, we already have put so much greenhouse gases into the atmosphere that this target or threshold likely will be passed in the next decade. The good thing is that it's possible to limit the global warming to 2 degrees if, of course, greenhouse gas emissions are being reduced. And regarding extreme weather, then this is a figure. It's not the most clever one. You may indicate or see that we have North America and Europe here, and EU, that's not Europe. So let's focus on our region. And the color is red. So then it means that it's today possible to detect an increase in extreme heat waves, both winter and summer in principle. And there are also 3 dashes between in this box, and that is that the confidence is high. And we see that almost all regions in the world experience today heat waves. So this is a very robust finding. And when it comes to precipitation, again, for Northern Europe, we see that the color is green. So there is an increase in heavy precipitation and the confidence is high. And this is the beginning of something that will continue. So we can expect more of heat waves, warm periods, summer and winter, and we can expect also both increase in the average precipitation, but also, and perhaps more importantly, very heavy rainfall. There are many challenges that we are facing. 2 of those, what could it be? It could be simply ourselves, the number of people on this planet. So this shows the number of people over the last 2,000 years in billions. I was born in 1965, then it was 3 billion of us. And today we are approaching 8 billion. So this is really a challenge. And it's even more a challenge because the 10% richest of humans are responsible for 50% of the climate greenhouse gas emissions. And one can say, okay, who are the 10% richest? Then you need to have an annual salary of around, in Norwegian crowns, is 300,000. So it will be about 30,000 euro. So certainly in Norway, we belong to the richest 10% of the world, and we are responsible for 50% of the greenhouse gas emissions. The poorest 50% of the global population are responsible for 7% of the emissions. So it's not only that we are many, but the richest one of us are polluting tremendously. So this is one indication of the many footsteps that we have. And when it comes to CO2 in air, then today we have the highest amount of CO2 over at least the last 3 million years. And we know that this increase in CO2 in air started at the onset of the Industrial Revolution about 200 years ago. We know that about 80% of this increase is caused by use of coal, oil, and gas. And the remaining 20% is to a high degree related to deforestation, particularly in the tropics, but also elsewhere. And an important thing, and very good for me, since I'm still in Bergeni, is that 20% of today's emissions, they will have a climate impact 1,000 years from now. So if I would visit you today, then actually 20% of the CO2 emissions from this airplane or whatever would have a climate impact 1,000 years from now. So this means that whatever we do today will influence not only the next 2, 3, 10 generations, but the climate for millennia. So therefore, it's very important to reduce the global emissions of greenhouse gases rapidly. So then we go to what we have observed. This is an animation showing observed temperature or variations in temperature since 1880 and up to today. Bluish colors indicate temperature below an average temperature, and reddish colors show temperature above an average temperature. And we stop here in 1941, and we clearly see the low temperatures in Central Eastern Europe. And my parents, they talk about the cold winters during the war, and this is clearly seen here. And the cold years, 40, 41, 42 in particular, they were cold by chance from a weather perspective. So it could be as warm as over North America or parts of Southeast Asia. But these cold winters, they had important implications for the war, as we know. Okay, so let's, so I should go to, yes, towards today. So then we can have a look year by year. Are there any changes? Still a lot of variability, but gradually things will or are changing. So this is 2020, and we all see that we still have variability, but there is also a very clear warming. And if we go back 100 years, and look at the temperature averaged over 10 years, 1911 to 1920, and this is the map. And this map shows the last decade. So there are 100 years between these two images, and they show what, when we talk about global warming, is this. There are still some regions that are possibly not warming, like south of Greenland here. It's a blue blob there, and possibly in Antarctica, but that is can be explained by this variation year by year. But over time, there is a warming. And the warming is stronger over land than the ocean, simply because the ocean or the water can absorb and keep a lot of heat. So we have observed about 1.1 degree warming, global warming. So that is over land and ocean. If we only look on temperature over land, the warming since pre-industrial time is 1.5 degrees. And we also see that as we go north towards Arctic and also away from the ocean, then the temperature increase even more. So by comparing Bergen on, so if I get the laser, that was, you may see it on the western coast of Norway, and then Estonia, then we have similar temperature increase, but a little bit stronger warming at your place, simply because you are further away from the open ocean. Okay, and we can put this into a perspective. So when was the planet 2 to 3 degrees warmer than today? That was actually 3 million years ago. So the warming that we could get in this century, 2.5 degree warming, could very well be the case. Then we have to go back 3 million years, and we, the modern man, Homo sapiens, have been on this planet for 300,000 years. So the change that is occurring now is coming very rapid. It's very strong. And actually, we are running into a climate now that we have not experienced at all. And for this single reason, I must say that I'm very concerned about the different types of heritage and cultures that we have that are going back some 100 years, perhaps a millennia, some places more, when we are facing a change that is that dramatic that we have now to go back 3 million years. If we go to your region, or essentially also could be my region in Bergen, this is the observed change in temperature in Estonia or in Tallinn. Starting in 1881, I know that some of the temperature records are going further back, but there are some gaps. So I started this figure in 1881, and it's including 2020. And 0 here is the mean temperature of the last century. And there are 2 yellow lines, and they indicate that there is a warming of 1.8 degrees over the last 100 years. And remember now, global warming, that was 1.1 degree and 1.5 degree over land. So here you have stronger warming than a global mean warming. And the warming is even stronger if you only look at the last 50 years, because the 1960s, 70s, 80s were somewhat colder. Okay, so yes, we see, and you have experienced also, a warming. But that's only one thing. Yes, and yeah, I had to make some searches on the webpage. January 2020 was very warm in Estonia, from 8.5 to 9.5 degrees above average. That's this is a strong winter heat wave, January 2020, and last summer was also warm. So this was headline from a web page. Finland is expecting 36 degrees centigrade, Estonia 37 degrees. So yeah, then there are many examples of increasing temperatures. Just so that we see by eye what is about to happen now, then the first part of this figure, that is what I showed before, that is the observed measured temperature in Estonia up to today. And then I have looked into the future, and I have assumed that there is an increase in temperature in this century in Estonia of 1.4 degrees centigrade. This is not much, and I have been quite modest. But let's add 1.5 degrees to what we have seen up to today. And let's also add variability, as you see the different bars here. They are both above and below this running mean curve in black. Then we get something like this. I don't say this will happen, but this shows that and illustrates, and that's important, that those that have been born in Estonia around 2000, they will hardly or never experience a temperature colder than the mean temperature of the last century. Remember that 0 on this figure, that is the mean of the temperature of the last century. So the forthcoming generations, they will experience a climate that have never been seen, absolutely not been seen before. And this also puts, again, the heritages and the cultures that we have into a perspective. So we are running into a totally unknown future when it comes to, in this case, temperature. And another thing, so if we go a little bit north of you to Helsinki, since the temperature measurements there started a little bit earlier, so we get an even larger perspective from 1829 up to today. Then in Helsinki, there has been an increase of 1.9 degrees over the last 100 years. So you had 1.8 degrees, so it's very comparable. So this is the annual mean. But if we go and look on April temperatures in Helsinki, then we see that in April, the temperature has increased by 3.2 degrees centigrade. And this is very important. And I looked a little bit into the data. So February, March, April has warmed a lot. And this is an indication that the seasonal cycle is about to change. So the winter season gets shorter. So the winter is coming later in the year. Spring is coming earlier. And the summer season then is getting longer and longer. And this will continue, and particularly with the retreat of sea ice in the Baltic, then particularly in the springtime, there will be huge differences in the future, huge differences. Yes, stronger, so shorter winters, longer summers or growing seasons. And yes. And then some other projected changes in your region. Temperature, there are different panels here. So this, the panel to the left, that's a scenario consistent with 2 degrees warming. The mid panel is consistent with a warming of around 3 degrees centigrade. The rightmost panel we can ignore. That is business as usual, but we are doing better than that. So I think we can focus on the left panel or the mid panel here. And the upper row, that is December, January, February. So that's the change in temperature in winter. And the lower row is for June, July, August. So that's change in summer. And if we go in and look at, so if I go to laser here, your region in winter. So we are talking about the warming of between 2.5 and 3.5 degrees centigrade or something like that. And in the summer, the warming is weaker. So it's 1 to 1.5 degrees, perhaps 2 degrees centigrade. But again, this is a lot. We don't think that 1 degree warming is that much, but it's a lot. And when it comes to rainfall, precipitation, then in blue colors, we see regions that where we expect increased rainfall in the future. This is by change throughout this century. And again, and the reddish warm colors, that's reduced rainfall. And we see that for December, January, February, there are bluish colors in your region. So you can expect more rainfall. And in summer, June, July, August, there could also be increase in the average rainfall. But this is a little bit on the uncertain side. It's more certain that the heavy precipitation, heavy rainfall events will increase, not necessarily that much increase in the rainfall in the midsummer in your region. And the units there, they are in millimeters per day. Okay, so warming for sure, averaged increased precipitation, possibly not in the summer, but more extreme rainfall in summer. Number of frost days. So this is a map, and there is a color shading here. So this indicates by 2050, so that's not that far away. That's 30 years from now. Then you can expect to have 1 month, 30 days with less with frosty temperatures. Where I am coming from, Western Norway, essentially the winter will be gone, certainly along the coast. There has also been observed changes in the number of days with ice in the Baltic region. So there are 3 locations here: Kemi, Loviisa, and Ute. And so there are the number of days. So they're of the ice season, and so there has been a decrease of 50 days or something like that since the measurement started in 1890, and this decline or reduced sea ice, the length of the sea ice season will continue. And that will have large seasonal implications particularly for your region. When it comes to wind, then it's hard to conclude. So the figure to the left is for the winter, the figure to the right is for the summer, and there are these hatched signatures here, and that means that one cannot conclude as of today. The IPCC report, nevertheless, states that one can expect more strong wind if the global temperature increases by 2 degrees or more. Just a little bit about sea level. I see that I don't have too many minutes left, but that's okay. So there are 2 competing factors here. One is that the sea level is increasing globally, but also in your region, as well as where I am, we have land uplift. So the land uplift in Estonia is about 1 to 2 millimeters per year, 10 to 20 centimeters in a century. So if we go to this figure, then it shows for Estonia that through this century, you can expect that the sea level increases by 30 to 40 centimeters, something like that. A little bit more stronger sea level rise where I live. And yes, so 30 to 40 centimeters sea level rise in this century. And then the last thing that I would like to point to, that is what is needed in order to limit global warming to 1.5 or 2 degrees. And this figure shows the emissions of CO2 in Estonia since 1959. So there was a lot of CO2 emissions up to around 1990, mainly from coal, then a decline, level off, and then a reduction again for the last some years. If we assume that all states globally are reducing their greenhouse gas emissions to with the same amount, then in order to limit the global warming to about 1.5 degrees centigrade, then we need to reduce our emissions by 11% per year. And this is the lowermost curve there. And essentially, we are talking about zero emissions in 2050. So if everyone, Estonia included, Norway as well, certainly, would reduce the emissions by 11% or thereabout, year by year, then the global warming could be limited to 1.5 degrees centigrade. This is not easy, because we have been through a COVID and still are into a COVID pandemic. And in 2020, the global emissions were reduced by 5%. So now we need twice as strong reductions year by year in order to be able to limit the global warming to 1.5 degrees centigrade. So this is next to impossible, I think, and many things that. When it comes to 2-degree target, then we are talking about a 4% reduction per year, and that's possible. Yes, so just to sum up, the temperature has been increasing, will continue to increase, particularly in winter. We can expect heat waves or warm periods, particularly in summer, but also in winter. There will be changes in the seasonal cycle. Winter season will be shorter, summer season longer. And this have many implications. Introduction of new species, for instance, including pests. We expect more average rain and even more and stronger extreme rain events. And where I live, humidity throughout the year is a very demanding problem now. Influencing essentially all of the wooden buildings. So that this is a great problem. Stronger storms may get somewhat more powerful, otherwise it's hard to conclude regarding wind. And sea level will continue gradually to increase along the coast. So that was my summary. And as I said, those that are interested can download or upload the slides. So this is my email. You can contact me, or I will pass the slides and the animations to the organizers. Yes. So then my time is out with overrun with a few minutes. So thanks for the attention.
Thank you very much. It was all again very interesting. We have 2 questions in Slido. Actually, one of them is not for you, but for my introduction. But nevertheless, I will ask you the same question. But it's more not in a climate science, but more on a economic policy side. What would be the effect of loss of jobs if we were to fulfill all the climate purposes, or will it bring along loss of jobs in industries, for example? If we want to cut emissions.
Yes, so I think this is the start of a new era. I think there are huge possibilities here for jobs for Norway, not in oil and gas, but just imagine the experience and the capacity in that industry that can be turned into, for instance, offshore wind parks, windmill parks. So that's one thing, there are many challenges, certainly, but what do we need? Okay, we are 8 billion people on this planet. the richest one of us are overusing the resources tremendously. So we need to start to think into a circle. So what we use need to be reused. And this means that, so there is a lot of possibilities there, of course. So once we have a cell phone or a computer, how to construct this in order for as much material as possible to be reused later on. So that's one thing. And when it comes to transportation, there will be, I think, also large changes. We will, most of the transportation will be powered by electricity. Today in Norway, I think 65 or 70% of the new cars are electric cars. I also know that Norway is not the typical country, but this will come. So yes, so huge possibilities, but also challenges. And in Norway, we have there is a kind of a war against windmills on land, and that is for good reasons, because we also need to maintain nature. We have a responsibility to maintain species, biotopes, and biodiversity in nature. So yeah, but how to do this?
Okay.
Many questions, and a lot of research needs to be done. But also we need to change our attitude. We need to understand that we have neighbors. We have many neighbors. We are not alone anymore.
Okay. So the effects are global. Another question here is about that there might be a curious positive effect of global warming, that less retrofitting is needed for the existing housing, meaning there is no need to reinvest or invest that much into making them warm, and that again might create less CO2 and waste. Do you think that the climate change is that permanent, that we need less insulation, for example?
But it's totally dependent on where we live. So if we live at a slightly lower latitudes, then the summer heat will be so extreme that we need to have very good air conditioning systems, and they consume a lot of power. So we actually live in a part of the world that is quite optimal, in that the summers are not too warm and the winters are generally not too cold. So we are possibly coming quite good out of this, but we are dependent on food. Where is the food coming from? For instance, and what about climate refugees? We are not talking about 100,000. We are talking about 100 million of people that cannot live anymore simply because the sea level is too high, it's too dry, there are no food. So how do we respond to this? What about the loss of biodiversity, species, locally in our place, but also on a larger scale, and the implications thereof when it comes, for instance, to insects or pests, etc. So there are so many unknowns in this in the system of the future. So I think that the best thing we can do is to sit down and really consider what we are doing today, how much we consume, and how we can improve on, or we simply have to think smart. So we need to reuse what we are using. And in Norway, we are over-consuming resources by a factor of 4. So this means that if we continue with our lives as of today, then we can do it from January to April, and then from May to December, then no consumption at all. So that's the challenge. And so this is serious business, absolutely. But there's also a possibility. But personally, I'm very concerned about all of the old houses, buildings, the history around that are going back, running hundreds, millennia of years.
Mm-hmm.
How can we maintain our history? Because we need our history, and the history is important for us.
Mm-hmm. Well, thank you very much. It's all very interesting, especially really if you combine not only the climate change but also demographic implications of those climate changes. Then the outlook does seem very gloomy. And I absolutely agree that everybody has to make an effort, not only governments or big corporations, but basically every consumer has to make an effort to cut back. Mm-hmm. Thank you very much. We were a bit over time, but yes, it was all very interesting. I hope all the listeners are agreeing that this plus 10 minutes was a good investment in time. Thank you, Helge, once again, and thank you for your very quick response, and it's good to see you today on the screen.